Good morning. In today's class, we will look at how to solve logarithmic equations. We've got our properties sheet in front of us as well. So here's our first example. We're trying to solve this for x. The first thing we'll do is divide the right side and the left side by 3 so that we have the logarithm isolated like this. Now take a look at the logarithm and notice there is no base indicated here. This means it's the logarithm of base 10, known as the common log. And you'll find this one on your calculators. So what we're going to do to solve this is the big switch to exponential form. So this means writing it 2x minus 1 is equal to, now here we write, the base is 10, the exponent is 1/3. You'll notice that the function 10 to the x is the inverse of the common logarithm. Okay, all we need to do now is isolate x, which means a little bit of algebra, including first adding 1 to both sides and then dividing both sides by 2. Now, to evaluate this, with our calculators, one option is to make use of that inverse logarithm button. So 10 to the x is up here, you see. So we go shift log to make that base appear. At this point, we simply put in the exponent. Now it's fractional, it's 1/3. So we have to bracket that. So 1/3 like this. So see, this means 10 with an exponent of 1/3. Okay, it's equal to this number. Then we still have to add 1, push equals, then divide by 2. Okay, so we do get 1.58 roughly when we round to 3 significant digits. Now the second question is actually really similar, except we don't have the common logarithm, we have the natural logarithm. So you'll find this has a base of e. Okay, so first step again, I'm going to divide both sides by 3. So the ln of 2x is 2/3. Then I'm going to do that switch in forms from logarithmic form to exponential form. The argument is 2x. We set that equal to the base, which is e, with an exponent of 2/3. To evaluate this, all we have to do now is divide by 2. So in punching this in, we use the fact that the exponential function is the inverse of that natural logarithm. So we're going to go shift ln to make the e appear. All we do now is immediately put in the exponent. And again, it's a fraction, so it has to be in a bracket. So 2/3. Close the bracket like that. Push equals, so that's e to the 2/3. Divide it by 2 to get our answer. So this is roughly 0.974. Okay. Let's look at number 3. Now, in number 3, we have 2 terms. They are both common logarithms with subtraction between them. So we can use property 4 in our first step, combining those logarithms. 15x squared over 5x will now be the argument. This is something that can be simplified using division. 15x squared divided by 5x is 3x. And now we are ready for the switch in forms. Again, there is no base indicated for these logarithms, so this is our common logarithm of base 10. So we write 3x equals 10 is the base, 2 is the exponent. So now here we know that 3x is equal to 100 and x is 100 divided by 3. And this number is actually exactly 33 1/3, which you can write it that way, 33 1/3. Or if you want to show it as a decimal, you write it like this, okay? This is now an exact number, not a number that has been rounded if you put this little dot here to show that the 3 is repeated. So either one of these forms is great for our final answer. Okay, let's look at another example. Okay, here we go. All three terms are logarithms with the same base. Only one of them contains the variable x. We might want to start, therefore, by getting that term by itself. So I might start that way this time. So I'm going to bring this to the right side so that it can be positive. So that means this term is coming to the left, so I will be subtracting it. Okay, so take a quick look, make sure you understand how we did that and why. So I wanted to isolate the term containing x here. Now, it seems like we're going to be using again this fourth property. However, we cannot do that until this 2 is moved. So we have to use property 5 before property 4. So the 2 becomes the exponent. Right there, 3 squared or 9. Okay, so first property 5, now property 4, allowing us to combine these such that the argument is a quotient. Okay, each side is now a single logarithm with the same base. And since it's an equation, this is the step at which we can conclude. The argument on the left is equal to the argument on the right. This means x is equal to 3 squared over 45, which is 9 over 45, or 1/5, or 0.2 if you prefer. Okay, so this question different from the first 3 that we did because all terms were logarithms of the same base. So our goal was simply to make each side a single logarithm of the same base and to isolate x. Okay. Example 5, we do not have a logarithm on this side here, so pay attention to that. So I think that what we'll do is just combine the logarithms here. But remember, you have to combine by using property 5 first. In other words, this coefficient has to be moved first, such that it's the exponent. Now we can combine these logarithms. And it would be 2 squared, or 4, over x. Again, because it's subtraction. Another example where it's subtraction. Now, unlike this problem, we do not have a logarithm on the right side. So what we have to do now to solve for x is the big switch in forms from logarithmic form to exponential form. Okay, so in that way, this is most like the first 3 examples we did. You see where we had just a number on the right side. And so all of these questions required us to use that switch in forms. What would it look like here? Well, the argument is 4 over x. I have to set that equal to the base of e with an exponent of -1. So we have 4 over x is e to the -1. How do we solve this for x? Well, you might want to do this kind of cross multiplication first. So 4 is x times e to the -1, right? Multiplication like this. Now to get x by itself, we have to divide both sides by this number, e to the -1. So 4 divided by e to the -1 is x. And this is, of course, the same as 4 times e to the 1. So you can punch it in like this, or you can change it to 4 times e to the +1 using your rules for exponents. Either way, so either put this in your calculator or this in your calculator to get x. Okay, so I'll show you. I guess I'll show you this form. 4 divided by e to the -1. 4 divided by, again, to make the e show up, it's shift ln. 4 divided by e. Now we have to put in an exponent of -1. -1. Like this. Push equals. Okay? And you can see what I'm getting here is roughly 10.9. All right, and maybe I'll show you if I did 4 times e to the 1, I'd get the same thing. 4 e1. That's what it looks like. 10.9 also, okay? Okay, so that was example 5. Couple more, okay? Let's take a look at this one. All terms are logarithms of base 7. So this will be more similar to question 4. Let's begin. These are the 2 that contain x. So let's begin by combining them. Now look, this time it's got a plus sign. So we're going to combine those such that we have a product in the argument. So it's going to look like this. It'll be x times 2x minus 5 here. And this is the point now that since we have one single logarithm on each side of the same base, we can immediately say that that is equal to that. So x times 2x minus 5 is 3. How do we solve this? Well, we've just spent a good portion of the course learning how to solve this. Open up the bracket first. 2x squared minus 5x is 3. We must make right side 0 like this, and then you can try to factor it if you like. You can use the quadratic formula if you like. You can also complete the square, but that would just be silly, right? So go ahead and use the quadratic formula, or go ahead and factor this. okay? This one is factorable. Sometimes, remember, they're not factorable. So how do we tell? So we would do here, the product is 2 times -3, which is -6. The sum is -5. The numbers that will work here then are -6, +1. If you find numbers that work, then you know it is factorable. If it's not factorable, you have to turn to your quadratic formula. Okay, so here I would replace the middle term with -6x, +1x. From the first two terms, we take out 2x. From the last two terms, we take out 1. So this makes our answers x minus 3, 2x plus 1. So the two values for x are found by setting these factors equal to 0. So we get x is 3 or x is -1/2. Now, the logarithm of a negative number is undefined. So this answer is not acceptable. The only answer that works is this one. X is equal to 3. Okay, so let's take a quick look at what we did. First, we combined the logarithms on the left. Each side was a single logarithm of base 7, so we equated the arguments and then we solved the quadratic. If you want, you would take this form here and use A is 2, B is -5, and C is -3. You could use the quadratic formula and you'd get these same two results, 3 and -1/2. Since the logarithm of a negative number is undefined, we keep only the answer of 3. Okay, let's just do one last problem together right here. Look, no logarithm on the right. So be mindful of that, but we've got our two logs here that can be combined since they have the same base. So let's start like that. It's x times x plus 2. Okay, so here's where it differs greatly from this example. We do not have a logarithm here, so we must do the big switch now. This means taking x times x plus 2 and setting it equal to 2 cubed. The base is 2, the exponent is 3. Base, exponent. So see the big difference from this question and this question? And it has to do again with the right side here being a logarithm, but here not being a logarithm. Okay, so that's 8. We still have a quadratic to solve. X squared plus 2x is 8, from which x squared plus 2x minus 8 is 0. This is also factorable. Product of -8, sum of 2. This means the numbers are 4 and -2. Since it's got a leading coefficient of 1, this is 1x squared. If we like, we can use the shortcut in our factoring. We know that there will be an x here and here, so the factors will just be x plus 4, x minus 2, like this. Okay, so you can use that shortcut if you like, or you can take the time to replace the middle term, just as we did here. Okay, but we use the shortcut in class when we have 1x squared. So what are our answers? -4 and +2. But the logarithm of -4 is not defined, so we keep just this answer of 2. Okay, so that's 7 examples for you to go over again on your own, replaying the video perhaps, And when you're ready, I'd like you to try the exercises in 13.6. You can try 15 as well as 19 through 29 odd. In Blackboard, I have my handwritten solutions to these problems posted. So if you get stuck as you're working on them, you'll have that reference for you. Okay, thanks a lot, guys. I hope you have a great day.